Hello, in this video, we will present a case study to draw fractals. Specifically, we're going to draw a Sierpinski triangle. Recursion is ideal for displaying fractals because fractals are inherently recursive. A fractal is a geometric figure, but unlike triangles, circles, rectangles, fractal can be divided into parts, each of which is a reduced size copy of the whole. There are many interesting problems of fractals. This section introduces a simple fractal, the triangle, Serpinski triangle. Sierpinski Triangle was created by a Polish mathematician. His name is Sierpinski. So this Sierpinski Triangle is from his name. So this is the Sierpinski Triangle. You draw the triangle here. This is the order 0, and this is order 1. So how do you get order 1? Order 1 is now you take the middle points and now draw one triangle on the top, then draw the one triangle on the left, bottom left, and draw one triangle on the bottom right. So then this is order 2. Order 2 is, look at now order 2. This triangle is same as this, except that this is a smaller size. You draw it 3 times in 3 locations, 1, 2, 3. This is order 1. Smaller size of order 1. For this top one is order 2, but it's smaller size, reduced size of order 2, reduced size of order 2, reduced size order 2. So that's really the key to discover the recursive pattern. Then you can develop a recursive function. So first, we are going to look at this animation here. This is for 3. So here's for 0, and this is for 1, and this is for 2. So this is what we have. And this is for 3, and this is for 4, this is for 5. So now we are going to write the code. We're going to write the code is we're going to write this is the class, Sierpinski Triangle class. So we're going to create the user interface is the init self this. Creating a window. And the window set a title, window height, width, and this is the canvas. We're going to create a canvas. So here's canvas, and now creating a frame in the window. So that is here is this, the button is display Sierpinski triangle, here is display. So this is self-display. So now what is self-display? So here we're going to get this 3 points. This is the 3 points here. When you look at the user interface here, this 3 points, P1, P2, P3. So this 3 points, the location here is P1, it is in the middle, and up, this is the 10. The pixel is 10 here. So this is P2 on the left. This is the P3 on the right. So this is the right for P3. And so we're gonna now display triangles. Here is the recursive code now. This is, we're writing this recursive method to display triangle. So look at this here, the order. It's very important to use. You see here is the how do you design this method here is order and with the 3 points. So this is the location of the point. This is the, for every point you have the XY location. So this point here is the X value and this is the Y value. So X coordinate, Y coordinate. And so if this is 0, you're going to draw this 3 lines to connecting 3 points to make the triangle here. So this is self dot draw line is P2 and P3. So this is draw P3, P1. And here you got this midpoint. So this is self dot midpoint. So this is here is to get the midpoint. So the midpoint. You get the midpoint, 3 midpoints. 1, 2, 2, 3, 3, 1. So if you look at this diagram here, this is 1, 2, 2, 3, 3, 1. And now you're going to draw P1, P1, 2, P3, 1. And this 3 triangles. So draw this 3 triangles here. So this is 1, this is order is reduced here. Order minus 1 is P1, P1, 2, P3, 1. So this will be self dot display triangle order minus 1. And this will be the triangle is the on the lower left side at the this is P1, 2, P2, and P2, 3. And the last one is this P3, 1, P2, 3, and P3. And to draw this. So the key is here is this recursive method. See how you implement this recursive method right here. That is all for this case study on drawing Sierpinski triangle. See you on the next video.